Rational inequalities. Well, what does rational mean? A over b, a fraction where a and b are elements of integers, b not equal to 0, cannot divide by 0. Fractions. An inequality. Well, greater than, less than, greater than, or equal to, greater than, or less than or equal to. There are a whole lot of inequalities. Now let's have a look at this one. Right, so there we are. Like in the equation, we multiply through by x, we get that. And we can swap it around. Notice that's quite natty. There are 3 less than x, x greater than 3. Aha! So for example, x cannot equal negative 1. That makes sense because x must be greater than 3. Duh. Really, what an idiot. Let's try. 3 over x. Let's put negative 1 instead of x, and we get negative 3. Hang on, 3 over x. So 3 over negative 1 equals negative 3, but this is less than 1. So what's happening here? When we multiply through an inequality by a negative, the signs reverse. I hope you remember that. So do not multiply through an inequality by a variable. Because if you multiply through by a variable, you don't know whether that variable is positive or negative. Instead, we have to do it this way. We convert the inequality to less than 0 or greater than 0. But the main thing is we need to have 0 on the right-hand side. Boiling it down simply to a case of positive or negative. Less than 0, greater than 0, positive or negative. So 3 over x less than 1 means 3 over x minus 1 less than 0. Now I'm going to find a common denominator so I end up with a fraction less than 0. Now I can reason my way through that. There are critical values. When is 3 minus x equal to 0? When x is 3. When is x equal to 0? When x is 0. Now look, I know we can't divide by 0. But 0 is the boundary between negative and positive. So therefore, if this is 0, we have a boundary between negative and positive. If this is 0, we have a boundary between negative and positive. So it means it's a turning point for positive or negative. So in this case, x equals 3 or x equals 0. So we're going to put them on a number line now. 0 and 3. Notice I put it in the right order. And we test to see which partition of the number line have numbers which make the inequality true. So I'm going to try a number less than 0. So if I put negative 1 in, I'll get 3 minus 1, which is 4 over minus 1, negative 4, which makes it true. There we are. And if I try a number between 0 and 3, such as 1, and I put 3 minus 1, which is 2 over 1, I get 2, which is not true. And if I test a number such as 4, 3 minus 4 is negative 1 over 4, which is negative a quarter, which is true. There we are. So therefore, we can say to make it true, x must be less than 0, or x must be greater than 3. Can't be equal to 3 because this started as saying less than. If it was or equal to 1, I would have had or equal to, and I would have had it or equal to for the 3. Let's have a look at this one. This is now 3 different factors, which means 3 critical values. 0 from that x, negative 2 from that x plus 2, and 1 from the negative x minus 1. Now we're going to make up a number line starting with minus 2, then 0, then 1. There we are. In ascending order, yes. Now we're going to test values. Now, in fact, unless you have a squared or something, they will alternate. you'll notice in the previous one, here we are, tick, cross, tick. So we could cheat a bit and say, well, all right then, we have this here, and I'm going to test a number anywhere really, but whatever's convenient. But it's going to include -2 because -2 will make it 0 and it's all equal to. It's going to include 0 because if x is 0, it makes the whole thing 0, which then makes it true. And it's going to exclude 1 because you don't want a denominator of 0. Now, if I test a value less than -2, so if I substitute -3 into there, I'll see if you get a number bigger than or equal to 0. And you'll find you won't. Now, from then, it's going to alternate. But you can test numbers to see. Now, bigger than 0, it's there, and it's there. Now, have a look. There means it includes there. So it's from -2 to 0, including -2 and 0. There means it's from 1, but not including 1. There we are, including it. So therefore, there's our result there. And this one, notice that it excludes the 1, includes but excludes greater than 1. Let's do another one. Remember now, I can't multiply through by x plus 1 because I don't know whether that represents a positive or negative number. So I move that to the left to make it a question of positive or negative. Common denominator. Here we are. Haven't quite finished yet. You'll see I don't really like that minus x squared there because that causes complications. So what I'm going to do is I'm going to multiply the top by -1, the right hand side by -1, and this must flip around. Notice how it's flipped because I've changed the sign of both sides. Please don't think you change that sign, and that, because if you change this and this, you'll end up without having changed the sign because you've changed top and bottom. But I want to change the sign of this, so either I would change that sign, which I don't want to do, because I'll end up with -x minus 1. So I'd rather change the sign of the right-hand side. Well, 0 stays 0. But notice I'm going to say it again. Multiply through by -1. That becomes that. That stays as 0, but that is going to flip around. Let's factorize. 1, 2, 3 critical values. There we are. And I'm going to put them in order on the number line. There we are. Now notice that it's all equal to 0. So therefore I will include the value of x that makes that 0. I'll include the value of x that makes that 0, but I will not include that because I cannot divide by 0. There we are. So I'm excluding -1. And I've tested regions. I'll tell you what I cheated. I go for 0 there because it's so much easier to substitute 0 to there. -1 times 2 is -2 over 1 is -2, which fits, therefore it's a tick, and therefore cross, cross, and tick. Now our areas or equal to, less than or equal to 0, so when it's equal to 0, we'll include that going that way. We'll include this here, but won't include that. So in fact, there is what we'll do. We'll include the 2 and going off that way, and we won't include the -1, but it'll be from there to there. So this will be greater than -1 or -1 less than, and it'll be or equal to 1 or equal to -2. So there we are. Or equal to 1, greater, x is greater than -1, x is less than or equal to -2.